Good morning students. This is video number 3 part 2 and here we will continue with chapter 2 elements, compounds and mixtures. Here we study topic chemical formulae of elements. Now all of you know that every element represented by symbol. For example, hydrogen symbol is capital H, carbon symbol is capital C, then nitrogen symbol is capital N, sulfur symbol is capital S, oxygen symbol is capital O. So, symbol of an element represents what beta? Symbol of an element represents one atom of element. One atom of element. Now, chemical formula of an element represents something else. So, what it represents? That is one molecule of the element or compound. Chemical symbol represents one atom and molecular or chemical formula represents one molecule. One molecule. For example, if we talk about oxygen element. So, for oxygen element symbol is capital O, where this capital O represents one atom of oxygen. But for oxygen molecule, chemical formula is O2 and this O2 represents one molecule of oxygen gas. This is one atom of oxygen element. This is one molecule of oxygen gas. Same way, if we write capital H only, it means that one atom of hydrogen. If we write H2, it means that one molecule of hydrogen gas. Next we have definition atomicity. This is number of atoms present in a single molecule of an element. For example, in oxygen gas, how many oxygen atoms present or how many oxygen elements present? 2. 2 written over here. So its atomicity is 2. Number of atoms present. Same way for H2, it will be again 2. So atomicity is nothing but number of atoms present in single molecule. Now, if number of atoms present will be 1, then we will call monoatomic element. Monoatomic element. All inert gases or all noble gases and all metals, they are monoatomic. Inert gases like helium, neon, argon, krypton, xenon, radon. And metals like sodium, iron, then magnesium, all are monoatomic. Means all having one atom in their molecule. Next we have diatomic molecules. Now if in molecule of element we will have 2 atoms. Di means 2. Di means 2. Atomic means atoms. So if we have 2 atoms in molecule, then we will call diatomic molecule. Example like O2, H2, O2, H2, Cl2, N2, Br2, I2. In all we have 2 atoms only. So these all are diatomic molecules. Now oxygen molecule is made up of 2 oxygen atoms. Because this is O2, so it is made up of 2 oxygen atoms. One oxygen atom will combine with another oxygen atom, will form O2 molecule. Same way hydrogen molecule made up of 2 hydrogen atoms. One hydrogen atom will combine with another hydrogen atom and will form H2 molecule. Same way Cl2 chlorine molecule, N2 nitrogen molecule, Br2 bromine molecule and I2 iodine molecule, all having atomicity equals to 2 and all are diatomic molecules. Next we have triatomic molecules. Tri means 3. So wherever we will have 3 atoms in molecule, we will call a triatomic molecule. Example is ozone having formula O3. Now here 3 oxygen atoms, they will combine, they will form O3. Next we have polyatomic molecules. All molecules having number of atoms greater than 3 are called as polyatomic molecules. Example is like molecule of phosphorus. Phosphorus molecule having P4 formula. Here 4 phosphorus, 1, 2, 3, 4. They will combine, they will form P4 molecule. Same way another polyatomic molecule like sulfur molecule having formula S8. So here 8 sulfur atoms, they will combine, they will form S8 molecule and its atomicity is 8. So what is atomicity of oxygen molecule? 2. Of hydrogen molecule? 2. Of nitrogen molecule? 2. Of ozone molecule? This is 3. Of phosphorus molecule is 4. And of sulfur molecule is 8. Oxygen, hydrogen, nitrogen, these molecules are diatomic. Ozone is triatomic and phosphorus and sulfur both are polyatomic having number of atoms greater than 4. Now we study little about ozone. Ozone is what? Having formula O3. So diatomic molecule O2, we know that oxygen gas we inhale, but this ozone O3 is different from O2. So ozone is pale blue in gaseous state and deep blue in liquid state, beta, and is present in upper layer of atmosphere and protect us from harmful ultraviolet radiations. Next, sulfur. It is non-metallic element and is present in many compounds, like present in cinnabar having formula HGS, present in galena having formula PBS, present in H2S gas. Next, hydrogen, which is gaseous in nature and is lighter than oxygen. Now, one interesting point about hydrogen, we have studied structure of atom. In the center of every atom, we have nucleus in which protons and neutrons present. Around nucleus, we have circular parts in which electrons present. But if we talk about hydrogen, in the nucleus of hydrogen, no neutron present. Underline, has no neutron in its nucleus. Only proton is there in the nucleus of hydrogen. Next topic is chemical formulae of compounds. Chemical formulae of compounds is symbolic representation of a molecule of compound. Now, molecule of compound contains atoms of different elements. Like we have studied, molecule of element contains same type of atoms, but molecule of compound contains different types of atoms. For example, water, in which we have hydrogen one and another oxygen atom. But in case of oxygen, we have both oxygen atoms. So oxygen is molecule of element and water is molecule of compound. So examples of a few chemical formulae of compounds, like first one, underline, sodium chloride. Sodium chloride. Sodium chloride. Sodium having symbol capital N small a, that is from its Latin name natrium, and chlorine having symbol capital C small l. So one atom of sodium will combine with one atom of chlorine and it will form sodium chloride molecule or sodium chloride molecule of compound, NaCl. Same way, water having formula H2O. Here, two atoms of hydrogen will combine with one atom of oxygen and will form H2O, that is the molecule of compound. Next, we have carbon dioxide. Here, carbon means capital C, di means 2, oxide means oxygen. So, one carbon will combine with two oxygens, di means 2 oxygens, and will form carbon dioxide having formula carbon means capital C and oxide means capital O and di means 2. So, two atoms of oxygen will combine with one atom of oxygen, give carbon dioxide. Now, here we have a few formulae of compounds, like zinc chloride, formula is ZnCl2, nitrogen dioxide, formula is NO2. Now, zinc means Z and N and chloride means Cl2. Nitrogen means capital N, di means 2, oxide means O. So, it is NO2. Calcium means capital C small a, oxide means capital O. So, formula is capital C small a capital O. Ammonia contains nitrogen and hydrogen atoms. So, formula is NH3. Nitric acid, wherever acid will be written, you have to note that hydrogen atom will be present. So, nitric means nitrogen and oxygen. So, formula is HNO3. Iron sulfate. Iron means ferrum. Symbol is capital F small e. Sulfide means sulfur. So, formula is capital F small e capital S. Aluminium chloride. Aluminium symbol is capital A small l. Chloride symbol is capital C small l. So, formula is AlCl3. Calcium carbonate. Calcium symbol is capital C small a. Carbonate means carbon and oxygen present. So, formula is CaCO3. Copper sulfate. Copper means C, capital C small u from cuprum, and sulfate means sulfur and oxygen present. Formula is copper sulfate, that is CuSO4. You have to learn all these formulas of compounds. Some formulas written over here. These formulas also you have to learn. Next topic is mixture. Now element and compound, pure substance, but this mixture is a impure substance. So mixture is impure substance which is formed when particles of two or more elements or compounds are mechanically mixed, not chemically, in any proportion, not in fixed proportion, and they retain their original properties. For example, this carbon dioxide is compound, we know. Water is compound. If we mix these two compounds, what we get? We get mixture. This NaCl is compound, this water is also compound. NaCl is salt and water is water only. So if we dissolve this salt in water, what we get? We get mixture. So mixture is a combination of two or more compounds or two or more molecules of elements. Examples of mixtures like blood, tea, cold drink, milk, air. Air, why air is mixture beta? Because in air we have many gases like oxygen, nitrogen, carbon dioxide, water vapors. So that's why air is a mixture, because air is a combination of more than two compounds or more than two molecules of elements. A mixture can be solid, can be liquid, can be gas. For example, blood, this is liquid mixture. Tea, liquid mixture. Milk, liquid mixture. Air, gaseous mixture. Same way, if we mix sand and salt together, that will be solid mixture. So soil is a mixture of sand, clay and various salts and remains of plants and animals. So soil is a solid mixture. Seawater is a mixture of several salts dissolved in it. This is a liquid mixture. Air is a mixture of several gases. This is a gaseous mixture. Now what are different properties of mixtures? First property is beta, the components are mixed mechanically only, not chemically. They can be mixed in any proportion, not in fixed proportion. Second property, individual components of a mixture retain their original properties, means their properties will not change. For example, if we dissolve salt in water, then again mixture of salt and water will have a salty taste. Next, the components of mixture can be separated by physical methods like winnowing, sieving, filtration, evaporation. All these methods we will study in another chapter. Formation of mixture does not involve any exchange of energy. Mixtures can be homogeneous, can be heterogeneous. Now what are homogeneous and heterogeneous mixtures? That we are going to study. So next is types of mixtures. Mixtures are of two types. One is homogeneous, another is heterogeneous. Homo means same, hetero means different. So what is homogeneous mixture? If components are distributed uniformly throughout the mixture. Means if composition of components will be same throughout, then mixture will be called as homogeneous mixture. Example, sugar solution, salt solution, milk and air. Heterogeneous mixture is what? When components are not uniformly distributed throughout, then that will be heterogeneous mixture. For example, mixture of iron fillings and sulfur powder. Means when we mix iron fillings and sulfur together, we will be able to see iron fillings and sulfur separately. But if we dissolve sugar in water, then we will not be able to see that where sugar molecules are. So that's why this is homogeneous mixture and this one is heterogeneous mixture. Now mixture can be gas in gas, can be gas in liquid, can be liquid in liquid, or can be solid in liquid, or can be solid in solid. Now here we see that we think that milk, honey and medicines, they are pure substances only beta, but they are not pure because they contain many other substances. They are called as their components. For example, milk contains fats, vitamins, carbohydrates, proteins, salt and water. So these all are components of milk. Same way, honey contains fructose and glucose and water. So these are components of honey. Same way, medicines contains many salts and all salts, they will be components of medicines. Next we have difference between compound and mixture. Now compound is what? Compound is anything that is obtained by combination of atoms, for example, or combination of elements. For example, carbon and oxygen combine, they form carbon dioxide, that is the compound only. Mixture is what? This same carbon dioxide when we mix with another compound like water, then we get mixture. So components are chemically binded, means carbon and oxygen both chemically binded with one another. But in mixture, when we mix carbon dioxide and water together, then mixing will be mechanically only, not chemically. Now components are fixed in number, means here in all molecules of carbon dioxide, one carbon and two oxygens will be present. No carbon dioxide molecule will be there with two carbon or with one oxygen or anything else. Okay, so components are in fixed ratio or in fixed proportion, but in case of mixture, components can be present in any proportion. For example, mixture of carbon dioxide and water, any amount of carbon dioxide can be present or any amount of water can be present. Now components cannot be separated by physical processes because they are chemically binded with one another, so they can be separated only by chemical processes, not by physical processes. But in case of mixture, they are only mechanically mixed, so they can be separated with the help of physical methods. Now here components do not retain their own properties, means carbon when combined with oxygen will form carbon dioxide, then properties of carbon will not be seen in carbon dioxide and properties of oxygen will not be seen in carbon dioxide. But in case of mixture, they will retain their properties, means when carbon dioxide will be mixed with water, then both will retain their properties. There will be no change in properties. Next we will study few examples of different types of mixtures. Gas in gas mixture, means both component will be gaseous in state. For example, air, nitrogen, carbon dioxide, water vapor, oxygen, all other gases, all are gaseous in state. So this is a gas in gas mixture and is homogeneous mixture because composition same throughout. Gas in liquid mixture, one component will be gaseous in state, second will be liquid in state. For example, aerated water, oxygen, carbon dioxide and water present, so oxygen and carbon dioxide gaseous components while water is liquid component, and this is homogeneous mixture because composition same throughout. Liquid in liquid mixture, for example, lemon juice and water both are liquid, petrol and kerosene both are liquid, oil and water both are liquid, petrol and water both are liquid. Now first one is homogeneous, second one also homogeneous, third one is heterogeneous because we know when we add oil in water, then we will be able to see oil and water separately. They will not mix with one another. So this is heterogeneous. Same way this one is also heterogeneous. Solid in liquid mixture, one component solid, for example sugar and sand, second component liquid, for example water. So sugar and water, sand and water, this is example of solid in liquid mixture. And first one is homogeneous because when we dissolve sugar in water, then it will hide itself in water, while sand particles we will be able to see, so it's a heterogeneous mixture. Next example is solid in gas mixture, that is smoke. Smoke having carbon particles and dust particles solid in state and air gaseous in state. So it is heterogeneous mixture. Next, solid in solid. Example is brass, which is a mixture of copper and zinc, bronze mixture of copper and tin, steel mixture of iron and carbon, solder mixture of tin and lead, gunpowder mixture of charcoal and sulfur. Brass is homogeneous mixture, bronze is also homogeneous, steel is also homogeneous, then solder is also homogeneous, but gunpowder is a heterogeneous mixture. Now with this chapter is finished.